Hi everyone, this is your struggling CS student, and today I'll be solving another LeetCode problem. Let's take a look at today's problem. LeetCode problem 983, minimum cost for tickets. Okay, so you have planned some train traveling 1 year in advance. Okay, the days of the year in which you will travel are given as integer days, and each day is integer from 1 to 365. Okay, train tickets are sold in three different ways. A 1 day pass. Okay, sure. The passes allow that many days of consecutive travel. Okay, so 30, okay, so for 30 days, you can travel for 30 days consecutively. On day two, yep, okay, understood. Return the minimum number of dollars you need to travel every day in the given list of days. Okay, let's look at some examples. This is we need to travel for 7820. Uh-huh. Here's one way to buy the passes that lets you travel on your travel plan. Day one, you buy a 1 day pass. And on day three, you buy a 7 day pass for this course, which covers 3 to 9. Okay. And on day 20, you buy a 1 day pass, which covers total you spend this many days. Alright. Cost stop length is 1000. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Here's one way to buy the pass. Day one, buy 30 days. 1 to 30. Okay. 1 day pass. Okay. So the constraints, day stop length is 365. Days of I, okay, days is in strictly increasing order, okay, so we don't have to sort days. Cost of Y is this much, okay, okay. Usually, okay, for minimum or maximum problems, you can usually think of some sort of greedy algorithm to solve it. If there is, for example, a locally optimal step where at each step, if you make the locally optimal decision, it gives you the globally optimal result. Now, I'm not sure if that's the case for this problem. If I were to tackle in the interview, I would definitely uh, go with the DP approach first because, in essence, at every day of the problem, we can always how should I say? We can either buy a 1 day ticket, 7 day ticket, or 30 day ticket, right? And then all we need to do is to find the next day where we will need to buy a ticket again. So how can we do that? Is through binary search, for example. Let's say at day one, when we buy a 1 day ticket, the next day we will need to buy another ticket again is at day four using binary search. Or we can buy, for example, like a 7 day ticket and they'll cover the range from 1 to, say 1 to 7. Oh, yeah, it's 1 to 7. I see. Okay, it's 1 to 7. And then you can buy a 1 day ticket. Well, you have to do the binary search to find the next day where you have to buy another ticket again. And then you just continue from there. So I think if we use a DP approach, the problem could be solved, and we only need to keep track of the day we are at right now. And I think that's it, right? Yeah, I think that's it. So let's go with that. Let's go with that. So at cache, we have DP. You know which day we're currently at. And actually, this is the day index, I guess. Day index. If day index is greater than equals greater than length of days, we are done. Then 0. Then 0. Do we return 0? Yeah, probably. So in this case, we can buy day one, buy 1 day pass. 1 day pass is equal some sort of recursive call. Uh, I will not write we have to calculate the next available day index using binary search, so I'll write that later on. They need a 7-day pass. For DP, likewise, 30-day pass. And then you just return DP of 0, for example, right? Here, return the min of day 1 pass by 1, by 7, and by a 30-day pass. So it's index plus the next available, this is day index, and the next available, the next day where we need to buy a ticket, likewise here. So when you do some binary search here, also if we buy the 1-day pass, then of course we need to take the cost of what? Cost of 0. Cost of 0 plus this. So yeah. So how do we calculate the next day that we need to buy the next day when we need to buy the other ticket? That means the current day, that would be days of day index, and then if we buy 1-day pass, that would be current day plus 1. Current day plus 1, and we need to look for this, and I think it's going to be a left insertion search. So bisect left on this, our current day low is equals to day index, and the high is equals to length of this. So this is the next available day. The next day that we have to buy the ticket for, if we buy a 1-day pass. This returns the next day index actually. So actually we just need to do this, I'm pretty sure. Yeah. So likewise here, what we are searching for is current day plus 7. Is it plus 7? Let's see again. 7-day pass on day 2. Then okay, I see. So this will be next day index. Is it -1? Because it's inclusive. This means what? This means on day 2, let's draw it out. Let's say on day 2, we buy a 7-day pass. Then we can do 2, 3, 4, 5, 6, 7, 8. So it's 1, 2, 3, 4, 5, 6, 7. Yeah, that means 2 plus 7, we're looking for day 9. We're looking for day 9 in our days array. Okay. Yeah, and it's bisect left, correct? Bisect left, days, current days. This will return us the index. And also, this is cost of 1. This is cost of 2. Current day plus 30. This is just next day index. That should be it, but let's give it a spin. Let's give it a spin. Oh, it's a cost. Okay. This index are arranged. Oh, greater than equals to. Okay, looks good. What's the time complexity here? Time and space complexity. So we can see that the day index, well, it only goes up to 365. You can say it's constant if you want to. And when we do the binary search, right, we are actually doing log days operation because it's only up to the size of the days in array. So it's more like I'll say the time complexity is O days times log days. All right, space complexity wise, that's O days. So yeah, quite happy I passed the sample test cases the first time around. I'll not put the TC here because I want to use the LeetCode's auto analyze function. Let's go. Alright, let's YOLO submit. Alright, it's accepted. Today is a fast one. Pretty happy with what I did today because it's DP plus binary search. So happy that I can recognize this quickly. Let's take a look at the runtime complexity. Is it what I say it is? Oh, it's linear. Nah, there's no way it's linear, right? Because day index is up to days, and we do log n operation at each step. Linear, this one I can believe. I think this is wrong. So let's take a look at the editorial. Yeah, top-down DP. Oh, actually, LeetCode has been kind of nasty. There have been I think 4 days in a row. It's all DP problems. Is this DP? Oh, this was also DP. 5 days. Is this DP? I don't remember actually, but I couldn't solve this one. Yeah, couldn't solve this one. Anyways, let's get back to the problem. Cursive approach, current day. Yep, that's what I thought of. Yep, we can. Yeah, each step we can either buy 1, 7, or 30 days. Okay. Yeah. Okay. Size of the DP. Need to find the answer for SS73. Therefore, it's okay. K is the. Wait, did they not use binary search? Current day plus 7. Let's see the Python solution. Is there a Python solution? No, there's a Java one. Okay. Is travel needed? Solve with the DP, the days, the cost, and the current day. Okay. Okay, sure. Don't need to travel to this day, move on to the next day. Travel needed. How do you calculate the travel needed? Okay. Solve DP days cost 1. What's this? The current day is the first day, okay. Move on to the next day. If already calculated, okay. Solve current day plus 1, current day plus 7, current day plus 30. Return DP. Yeah, is this correct syntax? Damn, okay. I didn't know you can do that in Java. DP current day is the math of this. Okay. Interesting. Did you really not need the binary search? Really? Yeah, exactly. What the hell? Let's see some of the comments. I think it works fine because for small constraints, there's no need to complicate the problem. Hmm. Let's take a look again. So are they just doing a linear scan? Is that what they're doing? Uh, Currently is greater. Okay. Ah, I see. Okay. Oh, okay. So this is where they do the linear scan. So instead of doing binary search, they're saying, okay, if we take the current day plus 1 and go to the next day, and um, we don't need to travel on this day, then we just recursively solve for the next day onwards. So you can kind of see how this turns into um, how should I say? As in the number of sub-problems you're iterating through will be up to 365 days because there are up to 365 sub-problems. So that's why they put here okay. In case the last day we need to travel and it's the last value in days. I see. Okay. Okay. Yeah, I think both works because the constraints and the constraints are not large enough. But yeah, thanks for watching this video. I'm happy to solve it in one go. So happy holidays and happy new year. Hope you enjoy this one. Thank you.